there, but like
I'll bring it
I'm
with
gonna
me.
like take pictures in it.
Mhm.
All right, ladies and gentlemen, welcome, welcome. Finally, here we go. So, blam, everything's working. Computer's freshly restarted. This is great. So let's see, problem 15 here. The instructions, directions say find the inverse of each relation and determine whether the inverse is a function. Okay? So first of all, the reason this is a relation is because for the input of 2, I have 2 separate outputs. Okay? So that's why this fails the function test. Now the inverse, if that was function f, I could say f inverse of x, I don't know, I guess, would have been the set 4 comma 2, 1 comma negative 3, and 8 comma 2.
So basically, you just switch their.
Yep, switching the x and the y's is the theme of inverses. But yeah, I did forget to talk about this kind yesterday, so that's
all you had to do for me.
and then we had to find out, is this a function or not? So if I input 4, is there any confusion as to what the output would be? No, everyone would say 2, right? If I input 1, everyone would say negative 3. If I input 8, everyone would say 2. And it's okay to have an output repeat, but I can't have a single input give 2 different outputs, which is what happened in the original. Okay? So this is a function. Question?
So I don't get like how you determine if it's a function. I mean, just because.
If I also had 4 comma 7 in here, so 4 gives me 2 separate outputs, it would have failed the function test. All right? Yep.
Because of the vertical line.
Yeah, that would fail if, graphically speaking, a vertical line would have passed through both of those points, is what it is. Yep. So let's see. How about some other questions here? 23. Oh, that's a. Let's see. It says find the inverse of the function, then graph the function and its inverse. Yeah, that happened yesterday in our classwork as well. It turns out any line that has a slope of negative 1 is going to be mirrored with itself when I graph it. So watch what happens here. So this happened in the classwork. It wasn't in the video yesterday. So I guess if I use the proper kind of whole procedure, step 1, replace f of x with y, so y equals negative x. Step 2, switch the x and the y, so x equals negative y. And then solve for that new y. So I would divide by negative 1 maybe, or multiply by negative 1, or just change the signs of both sides. Whichever you'd want to call it, and I get negative x equals y, and I could just switch that around if I want y equals negative x. And then last step is rewrite y as f inverse. So f inverse of x is equal to negative x. Yeah. And so notice it is its own inverse, right? I am my own grandpa sort of thing, right? And if I graph this, the graph of the original function, y equals negative x, it has a y-intercept of 0, a slope of negative 1, so down 1 over 1, down 1 over 1. It would have been like this, line like this, kind of at a negative 45-degree angle. And the graph of the inverse, if I graph, say it as an orange one, it's the same thing. So it'd be here, here, and then and draw the line, and it's exactly the same. What? Man, that reminds me of Michelangelo, the Ninja Turtle, not the artist, right there. I assume that Michelangelo, the artist, could draw a better graph than me. I assume that, maybe. But regarding Michelangelo, the Ninja Turtle, I'm not sure of his drawing ability, but I might challenge him in that. I wouldn't challenge him in a nunchuck fight, but maybe drawing ability, I don't know. So, and notice that both of these are in fact mirrored over the line y equals x, right? So when I mirror that, it just reflects right onto itself because it's perpendicular. So that's what is going on there. So that's kind of an interesting, unique case. How about another question?
Can you do the graph for 25?
25, that looks, 25 is a great one. I like it. Yep, the inverse is going to have a square root in it. And we wouldn't know how to graph the square root, but we would know how to graph the original and then mirror it, is how we could do that. So let's see. Let me walk us through the finding the inverse process. I guess this is already written as y, so I can switch the x and the y. So x equals y squared minus 9. I could then add 9 to both sides. So x plus 9 equals y squared. To solve for y, I would root both sides, plus or minus. Don't forget it. And I would get, where's my cursor? There we are. Y equals plus or minus the square root of x plus 9. Right, so here's my inverse. If you wanted, you could even call it f inverse of x. And the inverse is not going to be a function. Because of this plus or minus thing, it's going to mess that up. But let me graph this. Yesterday I graphed one of these, I think, using Geometry Sketchpad just for the accuracy's sake of seeing the clear mirror. But let's look at what the original is. So y equals x squared minus 9 is a regularly shaped parabola that's been shifted down 9 units. So it would be like way down here. All right, imagine that being negative 9. And then I'd do up 1 over 1, up 3 over 1, and then up like 5 over 1. It would actually have x-intercepts at 3 and negative 3. So it looks something like that, right? And then something like so. That's not that bad. It's a little pointier than I'd like, but it's okay. And now if I want to mirror this over my line y equals x, let's mirror a single point at a time. Because I would not expect you to know how to graph a square root thing like that. Eventually in Math 4 we'll talk about sideways parabolas and stuff. So here's the point 0, negative 9. So that's going to now become the point negative 9, comma 0. All right, I guess that'd be more kind of like over here. Right, and notice that it's mirrored, perpendicular, equidistant from the mirror line. Let's see, this point would be mirrored like here-ish. All right, this point would be mirrored. Actually, if that was right on the line, it wouldn't have been. It's not quite on the line, but yeah, it would be kind of on the other side there, I guess. And then this would be at, this point is at negative 3, comma 0, so now the new one is 0, negative 3. So it's a little bit weird. All right, so these are, mirrored, equidistant from the mirror line. And then this point here, mirrored, would be up here. This point here, mirrored, would be here-ish. Actually, yeah, technically here-ish. It would be helpful, I suppose, if I drew some tick marks here. And then this one, 3, 0 is now 0, 3. It'd be kind of like that. So I'd end up having this sideways parabola thing, like so. And like so. Technically, this point should intersect that line right there. And there's a point where they all three intersect there as well. Question?
How do you know where to draw the x equals y? Is it always goes through y equals 0, x equals 0? The intercept?
Yeah, it always passes through the origin, right? Because the y-intercept is 0 and the slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. It's just like a 45-degree angle line. So in the positive direction, that's the way I always draw it. So that's why I draw it kind of quick. I just think of it's 45 degrees and always at that direction. But
It's always in that direction. It never can be.
yep. Well, y equals negative x would have been this one. So it's going to have a positive slope. And yeah, if in case you're wondering, the plus version of this square root happens to be the top half of this, and the minus version happens to be the bottom half of this parabola. And this function would not pass the vertical line test. Failure. Blam. 2 hits. 2 hits, right? So it does not pass the vertical line test. So the inverse is a relation and not a function. Unless I broke it into 2 separate functions where I have one be the positive, one be the negative. But then I guess it's technically not the inverse anymore. But But that's the way you could trick a graphing calculator or software in order to graph that. All right. I mean, maybe one more question. Was there a third set of problems there? I don't know. Well, 27 is the equation of a line. Did we have to do any from like this batch down here?
31 through 35.
Yeah. I want to try to do one from a different set, just so I have each type represented. 33 looks a little bit more interesting, and it's kind of similar to 27, so I figured that could be helpful for us. Apparently the answer is no as well.
Excuse me.
Yep, you are excused. So the question here is, are these inverses? And the way I can verify that is I have to figure out what is f of g of x and g of f of x. And hopefully, if they were inverses, they would both equal what? What would they have to equal? Just regular old x, that's right. So for f of g of x, that means I'm going to take this function here and plug it into just the x right there. So function f is something minus 2 all divided by 3, right? And that something is going to be function g. So I'm plugging in 3x minus 2 into that set of parentheses. All right, so let's simplify this. I guess I can drop those parentheses. That would be 3x minus 4 when I combine the negative 2, right? All over 3. And if you want, you could break this into this. And that would just be x minus 4/3. But you could have spotted it here or here. That is not x, right? It's messed up by a little bit. So it's not going to be an inverse. But let's also, just to get some practice, figure out what g of f of x is. So the function g is 3 times my input minus 2. And my input this time is function f, which is x minus 2 all over 3. So when I multiply those, I can cancel those out. And I get x minus 2 minus 2, or x minus 4. So once again, no, not an inverse. So they are not each other's inverses. And just for practice, let me just find out what f inverse is, just to walk us through that. So for function f, it was f of x equals x minus 2 all divided by 3. So the first step, I would rewrite that as y equals x minus 2 all divided by 3. And then I would switch the x and the y, so x equals y minus 2 all divided by 3. And now I got to solve for the new y. What would my first step in solving be here for y? Solving for y.
Multiply by 3.
Right, I can't access that negative 2, so I have to multiply by 3 first. Right? So I'd end up getting 3x equals y minus 2. And then what would I do?
Add 2.
Add 2 to both sides. And I will get y equals 3x plus 2. Yikes. So I get f inverse of x is 3x plus 2. The plus sign didn't show up there well. So yeah, so if function g would have had to be 3x plus 2, so it was close to being the inverse, it was just off by a sign, right? And it would have worked out. But, so there you go there. And there we go. So that was some of our homework. Reviewing for our test is what we're doing today. So we'll be kind of covering all sorts of stuff, but thank you for watching.